Nitrogen is 78% of every breath you take. It just floats there, does nothing, enters your lungs, leaves your lungs completely useless. And yes, those should be pairs. Nitrogen gas is N2, two atoms locked in a triple bond, not lonely singles. Our artist apparently granted them the divorce early. Your body can't use it. No animal can use it. It is the world's most abundant freeloader. And then in 1909, a German chemist figured out how to crack it open. That one reaction now feeds half the planet. I'm not making this up. Ammonia, NH3 3 hydrogen atoms stuck to one nitrogen. It's a gas at room temperature, colorless, smells like a cat forgot where the litter box was. You know the smell. Everyone knows the smell. But here's the thing about ammonia that makes it one of the most important molecules in history. Plants need nitrogen to grow, all of them. Every leaf, every root, every grain of rice. And the atmosphere is full of nitrogen, 78% full, but atmospheric nitrogen, N2, is held together by a triple bond, 3 bonds, locking those two nitrogen atoms together like they're handcuffed to each other at a concert they both want to leave. That triple bond takes about 945 kilojoules per mole to break. For context, that's one of the strongest bonds in all of chemistry. Nature figured out how to do it. Certain bacteria in the roots of legumes, beans, peas, clover, they have an enzyme called nitrogenase. It cracks the bond slowly using a ton of energy, but it works for most of human history. That was it. That was the only way nitrogen got into soil. Bacteria or bird poop, guano, Chile had entire mountains of it. Countries fought over bird poop. That is a real sentence I just said. Then Fritz Haber, 1909, he figured out that if you take nitrogen gas and hydrogen gas, heat them to about 400 degrees Celsius, squeeze them to 200 times normal air pressure, and run them over an iron catalyst, you get ammonia. N2 plus 3H2 gives you 2NH3. Carl Bosch scaled it up to industrial size. We call it the Haber-Bosch process, which sounds like a law firm that handles divorce cases for molecules. That reaction now produces about 175 million tons of ammonia every year. About 80% of it becomes fertilizer. Half the nitrogen atoms in your body right now were put there by this reaction, not by nature, by a factory. One chemical process feeds roughly 4 billion people. Picture that, 4 billion. The flip side, all that nitrogen we're pumping into soil doesn't stay in soil. Rain washes it into rivers. Rivers carry it to the ocean. Algae eat it. Algae bloom. Algae die. Bacteria eat the dead algae. Bacteria use up all the oxygen. Everything else in the water suffocates. The Gulf of Mexico has a dead zone the size of New Jersey every summer, fed by fertilizer runoff from the Midwest. We're not running out of nitrogen. We're drowning in it. And Haber himself, the man who saved billions of lives with one reaction, he also pioneered chemical weapons in World War I. Chlorine gas, he supervised the first large-scale gas attack at Ypres in 1915. His wife, Clara Immerwahr, also a chemist, shot herself 10 days later. He won the Nobel Prize in 1918 for the ammonia, not the chlorine. The committee did not mention the war. One reaction, that's what separates a planet that can feed 8 billion people from one that can feed 4, one triple bond, one iron catalyst, one set of conditions a chemist worked out in a lab in Germany before the First World War. The chemistry is simple. What we've done with it is not. Thanks for watching. If you want more of this, hit subscribe. I'm Kaito, and this has been Chemistry Unpacked. Catch you at the next reaction.